All right, now we are going to discuss one of the most important alternative to net present value, the internal rate of return. As we will see, the IRR is closely related to the NPV. Sometimes is almost identical. With the IRR, we try to find the single rate of return that summarizes the merits of the project. We call this rate to be an internal rate of return because it only depends on the cash flows of a particular investment inside of the company, not on rates offered elsewhere. All right, so to capture the main idea of the IRR, let me give an example. There is a project that costs $100 today and pays $110 in 1 year. So what is the return on this investment? So what would you say? Right? It is very natural to say that the return is 10%, because you get another $10 in a year, beside $100 of your investment. So in this case, the 10% is the internal rate of return, right, of the investment. So can you say that this project with the 10% of internal rate of return is a good investment for you? What is your answer? The answer is that depends on the criteria you set up for this investment. I mean, if the required return for this project is less than 10%, you can say that you will invest on this project because the internal rate of return for this project is higher than the predetermined the required return of the 10%, right? So the IRR rule is that the investment is acceptable, if the IRR exceeds the required return. Also, if you have some multiple choices, you can select alternatives with the highest IRR. All right. So let me tell you about the advantages and disadvantages for this criteria IRR. One of the most advantageous feature of the IRR is that it's very easy to understand and communicate. The saying that the IRR is quite easy. Just a certain percent of the return you can get from this investment, right? It's very simple. It's very easy to communicate. But there are a lot of disadvantages for the IRR criteria, because it does not basically distinguish between the investing and borrowing. And also there may be multiple IRRs for the project, And there could be some problems with the mutually exclusive investment of the multiple choices. So I will discuss these issues later in this slides. So let me move on the example of the IRR. No, let's consider the following project. The initial investment is $200, and year one you will get the $50, and year two $100, and year three $150. What is the internal rate of return for this project? Please, please make sure that you are understanding. You can understand the formula uh, for getting this the IRR like in the bottom line. Again, the IRR is the internal rate of return to make the net present value equal to zero. You know, so you can write down like that the formula to get the IRR. So you know all of the cash flows from this project and the initial investment, you know, you can consider with the time value of money on the right hand side, and make the present value of those total, total present value of the cash flows, make to be zero, right? The NPV to make the NPV equal to zero, right? So can you get the answer? Can you get the rate of return? 19.44%, right? Just try. All right, if you want to get the answer, get the solution with your just calculation, it is not you know not not easy. Just if you have some financial calculator, it is very easy. But if you don't have the financial calculator, you need to make some adjustment of calculation, right? So like this, you know, just try and error method. If you want to get the IRR without the financial calculator, you just need to you do some repeat, like a try and error, like this, Just put the number from zero and increase the number, right? As IRR. Let's see. If the IRR, if you put the IRR as zero, what is the NPV? Just 100, right? Right? You can see that if IRR is zero, the NPV is just 100 as a definition, right? What about 4%? If we put the 4% as an IRR in this formula, you can get the no NPV is 73.88. What about 8%? If we put the IRR as 8%, you can get the NPV like 51%, 15.11%. If you put the 12%, you can get the NPV like 31. So you can try and error, and you can identify that maybe the IRR of making the NPV equal to be zero will be located, it will be lying between the 16% and 20%, in this range. So after repeating some trial and error, you can get the 19.44% as the internal rate of return, right? So you can see that the IRR is actually you know, the intercept of the axis. If you graph NPV in the y-axis and the IRR in the discount rate is x axis, you can get the IRR as the x-axis intercept. So in this case, in 19 point, 44% is the IRR, right? And you can also you can get the IRR with the spreadsheet. This is more easier way to get the IRR. So you can use the IRR function. In the Excel provides you with the IRR function is very easy function. So just let me try. All right. So you can try with the spreadsheet on the slide. Just plug in, just put the spreadsheet, and you will find some number of the NPV, and then you just put the IRR function and put the NPV. You enter the range of cash flows, beginning with the initial cash flow, and the IRR number will show up. So default format is 4%. So you can just increase the decimal prices to arrest 2. So it is easier for you. So let's try. Is it all right for you? Is it easy? Is it easy for you to get the IRR with the spreadsheet? All right. So let's move to the problems with internal rate of return. So I mentioned that there are some drawbacks with the IRR. Basically speaking, the IRR and NPV is identical. The NPV rule is the NPV. You can accept the project if the NPV is positive. So criteria is 0, and the IRR is the discount rate which make the NPV equal to 0. So by definition, the IRR and NPV is identical, but the IRR has more problems than NPV because the following reasons. So like there could be a multiple IRRs, and there could be a scale problem with IRRs, and there could be a timing problem with IRRs. All right. So let us discuss about these problems with IRRs one by one. All right. Let's just think about the mutually exclusive project, right? Versus independent project, right? So, you know, let me just explain the independent projects first. Independent means, you can accept or reject one project, without any consideration of other project. So you can consider only this project only, all right? So you can consider only the, you know, the predetermined criteria for accepting or rejecting for this project. And if the criteria exceeds the minimum acceptance level, you can accept the project. Or if it do not exceed the minimum criteria, you should reject the project. So this is independent project, right? But if you consider multiple choices at the same time, so I mean, you need to consider a lot of various, several different kind of, project at the same time. For this case, we call this a mutually exclusive project, right? So you need to select one. Only one of the several potential projects can be chosen, you know. So for the mutually exclusive project, you need to rank all alternatives and select the best one. So I mean, the if you just use the IRR, there could be some problems like multiple IRRs and just the timing problems. Like those problems can be observed with mutually exclusive project, right? So let me tell you about this. All right, for the multiple IRRs, all right. Let's assume the cash flows like this. Initial investment is $200. In year one, you can get 200 US dollar cash inflow. In year two, you can get $800 cash inflows. And year three, finally, you will have like 800 cash outflows. There are two cash outflows, you know, for the year zero and for the year three. So which one should we use? There are two IRs for this project. Would you just consider the IRs for this project in 1 minute? All right, let's see. Let's see the answer. All right. All right. Let's see the NPV and IRR formula again. All right. And just put the cash flows numbers for this case, and you can see that there is a there are two different IRRs for this project. First one is 0%. At the 0%, it intercept the x-axis, the discount rate, and 100%. Another IRR is 100%. It intercept x-axis. So if you just put the 0% for the formula in the formula, you can see that the NPV is 0. And if you put the 100% in the IRR, you can also see that NPV is 0. Can you see that? Just let's try in 2 in 2 minutes. 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 2 All right. So can you identify why is the NPV is zero when the IRR is 0% and also IRR is 100% with this formula? All right, good. So the conclusion is that there are two different IRR for this project. So it's confusing, you know. So that is a very critical problem for the IRR. So if you use the MPV is there is no problem like this. But if you use the IRR, there could be the problems of the multiple IRRs. So you cannot choose. You cannot use the IRR as a credible criteria for the investment in this case. All right. So and then let me move on the next problem, the scale problem. All right. So let's say that would you rather make a 100% or 50% on your investment? What if the 100% return is on a $1 investment, while the 50% return is on a 1,000 US dollars investment, right? What if? What if in this case? So in this case, you can say that the 100% is better than 50%? No, absolutely no. You know, the 50% of the investment is better because the NPV is the variable investment is much bigger than the variable investment is 100%. You know, so there could be like this scale problem always. So if you use the IRR as a criteria for investment, you need to check very carefully, this scale problem. Let me move on another critical problem for the IRR, the timing problem. The timing problem. Let's see. Let's assume that the project A, the cash flows of the project A are like this. No, the initial cash investment is 10,000, and the year one you can get the 10,000 US dollars, and year two 1,000, year three 1,000, right? And there is another project, project B. The cash flows of the project B are like this, that the initial investment is 10,000 US dollars, and then you can get 1,000 year one, 1,000 in year two, and 12,000 year three. So can you identify the difference between two projects? Project A is actually, have a bigger and a big, cash inflows in a very early stage, while the project B provides you the very big lump sum of cash inflows in the later of the stage. So like for these cases, you can there is very high probability you can get some timing problem, because the cash flows, the timing of the cash inflows is quite different, between the project A and the project B. So let's see. Let's try to make IRR to get the IRR for the project A and project B. So I will show you the answer, but please try in like 3 minutes. All right. Let's see the formula, the, for the project A, you know, with the formula of the IRR, you can get IRR 16.04%. And for project B, you can get IRR from the formula like a 12.94%. What does that mean? You know, the project from the IR point of view, IRR point of view, project A seems to be more profitable project than project B, because IRR is higher. I'm sorry, there is some typo, in for the project B. For the in the formula, the cash inflow in the year one is the 1,000, not 10,000 for this, right? Right. Please, just correct this number as the 1,000, right? Right. So let me show you the graph. The y-axis is the NPV, and x-axis is the discount rate. So just you can see that the relationship between them is different for project A and project B. The green line shows you the for the relationship between them for project B. The blue line shows the relationship for project A. So and we already calculate IRR like 16% for project A is like this, project A, the blue line. So intercept at 16.04%, uh, the x-axis, and the project B intercept the x-axis at 12.94% IRR, you know. So these IRR numbers, so we already, calculated. And you can find another one, like an incremental IRR, like a 10.55. What is the 10.55? This is like a crossover point between project A and project B, You can identify that before, the incremental IRR, the project B is much, you know, has much higher NPV than project A. And after the incremental IRR, the NPV for the project A is much higher than project B. What does that mean? What does that mean? You know, so what is the NPV for the projects are changing, as the discount rate are changing. So, I mean, so this means that if you just use the IRR as a criteria, you just conclude that the project A is more profitable than project B because the 16% is higher than 12%. But it is not always true. It is only true if, like, the discount rate is higher than 10.55%. just right hand side for this area. If the discount rate is less than 10.55%, the conclusion is inversed. The project B is better than project A. So you know if you conclude with IRR, you can make an error. You can make a serious error. You know. So this is the one of the critical drawback. Of the using IRR. So this we call this is the timing problem. So can you understand? Right. All right. Let me discuss why this problem happened. Intuitively, more intuitively speaking, you can understand, I believe, because project A's get a bigger cash inflows in the early stage, so it is less sensitive to the discount rate. But project B has bigger cash inflows in the later stage, later period. So it is very, very highly sensitive to the discount rate, you know. So so because of those difference, because of those difference of the timing of the cash inflows, project B is more sensitive to the discount rate, and while the project A is the sensitiveness to the discount rate. So 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 if when the discount rate is lower, project B is much profitable. But if the discount rate is higher, project A is much profitable because the project B is quite sensitive to discount rate because of its later bigger cash inflows like this. You know, it is. Can you understand it intuitively? Intuitively, you know. This is quite important for you. All right, let me just explain how to calculate the incremental IRR. Incremental 10.55%. How to calculate this? This is simple. Just you need just compute the uh, difference between the cash flows A and B like this. Project the difference the cash flows project A and B like this. You know this 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 row is the first this difference from A and B. This is difference from B and A. It's the same. Uh, the you know direction is different, but the number is same. So just to calculate the NPV for this cash stream, you know, so like this. So like NPV is 0 to make the cash streams discount cash flows for this or for this, you know, make equal to 0. So and you can get the incremental IRR 10.55%. All right. Either way is the same. Either way is the same. All right. So so if anybody asks you about what is the incremental, IRR for these two projects, just you can get you know, through this process. Okay. All right. Let me just summarize you know, the NPV versus IRR. Basically speaking, the NPV and IRR is identical by the definition. Generally gives the same decision for you, but there are many exceptions. This is important for you because, like if the cash flows is non-conventional, like cash flow signs change more than once, uh, there could be multiple IRRs. So there are some there could be some problems for you. And if you need to make a choice between the multiple choices, in other words, under a mutually exclusive project, you can make some mistakes, just like just we have discussed with this example, right? So timing of cash flows is substantially different, important, okay? If the time of cash flows is substantially different, or initial investment is substantially different, there could be a very, you know, uh, mistake for you if you use the IRO, instead of NPV. If you use the NPV, you can avoid these problems. So in general, the NPV, many people saying the NPV is, just a better criteria for the investment. But uh, as I mentioned, the IRR has also have some advantage, very good, big advantages. Like it's very easy to communicate each other. It's very, that is very strong point, strong benefit for the IRR. So, but you need to keep in mind that there are some very serious drawbacks for the IRR, like non-conventional cash flows or mutually exclusive project circumstances. So remember, we are ultimately, interested in creating value for the shareholders, for the company. So the consideration for the higher NPV is always important, you know. So regardless of the relative returns. But sometimes we cannot estimate the NPV because, uh, you know, to get the NPV, we need to know the discount rate, appropriate discount rate. But sometimes we cannot use the appropriate discount rate. In the case, we can still estimate the IRR. So in the case, the IRR is more practical, method to use. So so you can consider those criteria, depends on your environment, business environment. But in general, say that you can say that NPV is most preferable, criteria than the IRR in terms of measuring, measuring the how to contribute to the stakeholder. I'm sorry, the shareholders value. NPV is more direct and more clear measurement. Okay. All right. And then we can, we can discuss you can use the profitability index. This index is actually very similar to the NPV, you know. This is the, you know, ratio of the total present value future cash flows to the initial investment. So if the PI is higher than 1, we can accept the project, and less than 1, we can reject the project, right? We can select the alternatives with the highest PI, right? Profitability index. This index also has some disadvantage, like there could be a problems with mutual exclusive investment, and has some advantage of easy to understand, easy to communicate, right? All right, let me conclude today's class with the following, table. The conclusion is that actually the use of the the investment criteria is very different. It varies by industry and by company. Some firms prefer the payback period method. Some firms prefer like NPV. Some firms prefer like the internal rate of return criteria. Or some firms prefer just accounting rate of return, because accounting information is most accessible, is to get, right? So the table shows you the which investment criteria using is preferred by the financial manager, all right? So 75% is preferred, the internal rate prefer internal rate of return, and almost the same percentage, same 74.9% prefer the net present value, and 56% prefer payback method, 29% prefer discounted payback, 20% prefer accounting rate of return, and then 11% is profitability index. All right. So there are many, criteria for investment rule, and also there are many of preference for the financial managers. All right. So I'd like to ask you just to keep in mind this, usage of this practice of the capital budgeting, and uh, just apply, just to use for your, the future career. Thank you.